Good morning, everyone. We are Jerry and Jack from BGIC-GLOBAL, and we are the Formaldehunters. So I'm not sure if any one of you have heard of the recent Chinese news. Well, Wang, an employee of Alibaba, one of the biggest and strongest companies in China, was infected with leukemia and unfortunately died after living in a rent house for 3 months. Later, Zero, a major Chinese apartment rental service provider, was sued by Wang's family because it was revealed that its apartments contained excessive formaldehyde. Later, the company is sued by other inhabitants for the same reason. Although there is no direct correlation between inhaling formaldehyde excessively for 3 months and getting leukemia and even die, it is certainly unhealthy or even dangerous to expose yourself in an environment with excessive formaldehyde. In fact, our team has started looking at the issue of formaldehyde months before the news happened. Formaldehyde is a pungent, odorless, and colorless gas, but it is not harmless. Direct contact with formaldehyde may cause dermatitis, skin necrosis, and freckles, and inhalation of formaldehyde may cause bronchitis, respiratory tract infection, and asthma. We also conducted research on the regulations on formaldehyde content and found out that the maximum allowance for indoor space formaldehyde content is 0.08 milligrams per cubic meter. And the maximum allowance for furniture's emission of formaldehyde is 0.124 milligrams per cubic meter. However, there are several issues surrounding the regulations. First, the inspection mostly occur only at the large shopping malls, leaving out the smaller shopping malls undetected. Second, many merchants make false advertisements, claiming that their furnitures contain 0 or no formaldehyde at all, which is impossible. And third, the emission of formaldehyde from furniture is a long-term process, meaning many merchants could have, like Zero, could have cleaned the formaldehyde prior to the inspection, but shortly after the inspection, formaldehyde will once again become excessive. So to find out the most proper product that is desired by the public, we conducted product research and customer survey. So from the product research, we compared existing products on products that can detect formaldehyde and remove formaldehyde, and found out that most products are either too expensive or ineffective. And from the results of our market survey, we found out that most users are looking for an inexpensive, safe, and effective product. Therefore, we decided to create a product that can both detect and remove formaldehyde, but at the same time be safe, effective, and inexpensive.
Okay, hello everyone, I'm Jack. As my partner Jerry mentioned as the conclusion of our survey, we are going to produce a product that can both detect and decompose formaldehyde. Therefore, it is obvious that formaldehyde is an essential material that will be frequently used in our laboratory. As a result, we need to know exactly how formaldehyde performs in the environment. So we conducted a volatilization curve test for formaldehyde. From the original concentration of 37% concentrated formaldehyde solution to the one that diluted 10,000 times, we conducted 5 concentration gradients. And we are going to focus on 2 of them. The left one is the one that diluted 1,000 times. And as you can see, the Plato concentration is around 0.6 milligram per cubic meter. And according to our survey and research, the maximum concentration of formaldehyde in the open space is around 0.6. Therefore, testing our engineered system under this condition can allow us to test the efficiency of our bacteria. And the right side is the one that diluted 10,000 times. And the Plato concentration is around 0.1 milligram per cubic meter. As my partner Jerry mentioned before, the maximum concentration of formaldehyde regulated by China's government in Newhouse is around 0.08 milligram per cubic meter, around 0.1. So testing our engineered system under this concentration actually allow us to simulate the real situation in Newhouse and also allow us to test the sensitivity of our engineered system in this specific concentration of formaldehyde. Then let's talk about our project. Our project can be divided into two parts, the detection part and the decomposition part. In detection part, we transform three parts, PFRMR, BGFP, and FRM. PFRMR is enhanced formaldehyde inducible promoter, which retains higher formaldehyde responsiveness than its natural counterpart, PFRM. Actually, PFRM was tested by a Japanese group in 2012. This group is called TMU, and unfortunately, there wasn't results came out. And according to our surveys and researches and references, we believe that PFMR will perform better under fluorescent formaldehyde environment. And EGFP is enhanced green fluorescent protein, which can emit green fluorescent when expressed. And FRMR is a regulator in our engineered system. With the addition of this part, we can impose a negative regulation of PFRMR. So how does this system work? When formaldehyde is absent in the environment, FRMR will express the activity of PFRMR. And when formaldehyde is present in the environment, the molecule of formaldehyde will bind to the molecule of FRMR. Thus, the inhibition effects on our promoter PFRMR will be lightened. And the downstream gene, EGFP, will be activated. So that's our design. And we carried out a huge amount of experiments to verify that our parts are workable. And this is the results of one of them. As you can see on the left side, we have control group, and in the control group, we have BL21 strain with no plasmid transform. And in experiment group, we have BL21 strain transform the three parts mentioned before. And as you can see, there's one curve that emits clearly higher level of fluorescence than others. And let us simplify this curve. On the right side, there are only two curves now. One curve is the control group, the lower one, and one is the experiment group, the higher one. It is obvious that the difference between the two curves actually increases with time passing, indicating the expression of EGFP in our engineered system, thus meaning that all parts are working. So that it is our detection part, and in our decomposition parts, we transform two parts, PJ23-119 and GFA. PJ23-119 is a regular promoter that frequently used in our laboratory. And GFA has its full name called glutathione-dependent formaldehyde activating enzyme. Actually, with addition of this part, we can build up an intrinsic pathway inside our bacteria, as shown in the right side of the slides. Finally, formaldehyde will be decomposed into formate, thus fulfilling our aim of decomposing formaldehyde. And in order to verify our parts, we also conducted a huge amount of laboratory work. But unfortunately, among all the groups, the following one is the only one that can indirectly indicate the activity of our parts. In our experiments, we mixed two strains together in ratio of 1:1, as you can see on the left side of the slides. There are two plasmids, and each one represents one strain. And the results is on the right side. There are three curves on the graph. The lowest one is the control group, and the middle one is the experiment group with one strain, the strain that transformed EGFP plus PFRMR plus FRMR. And the highest curve, the curve which emits the higher level of fluorescence, is the experiment group, has two strains mixed together in ratio of 1:1. And our explanation to this situation is that GFA started working after formaldehyde was added into the solution, thus creating a more friendly environment for our bacteria, and more bacteria can survive. Due to some time limitation and failures in our experiment, we didn't carry all of our procedure in our laboratory, but we have detailedly planned our future improvements. The first improvement is replacement from EGFP to nano-Luc, because although EGFP can emit green fluorescence, that fluorescence can only be visible by using special instrument. So that will be really convenient for our consumer to observe. And with the replacement from it to nano-Luc, which is a kind of luciferase, our bacteria can emit luminance, which is visible by naked eyes. So that will be much more convenient for our consumer to observe. And the second improvement is addition of another promoter P-lag into our detection part. Because in our initial planning, both our parts FRMR and FRMR and EGFP will be regulated by one promoter, PFRMR. So with the addition of P-lag, two of our parts will be regulated individually. And this following chart is the conclusion of all the trials we have already done and our future plans. Although we have faced many failures in our experiments, we will keep on conducting our project in our lab. And we will go back to our lab immediately after the Jamboree. Besides focusing on the procedure of our experiments, we also pay heavy attention to the biosafety during our experiments. As you can see in the first graph, all of us are required for accepting a strict biosafety training and examination before we are allowed to enter the laboratory. And all of our experiments are carried out in hoods, which can not only prevent the leakage of formaldehyde, but also prevent the contamination of bacteria. And as you can see on the right side, these are the pictures of our DIY device. In order to prevent the leakage of formaldehyde, we designed this device. And these are all the references we use in our laboratory. So that's all the parts in our experiment.
Okay, so based on the experimental ideas, we have created our product design. The product consists of mainly 4 components: a filter screen, an injection hole, an observing window, and a mixture of McConkey BL21 powder. The user will receive a Formaldehunters kit that contains the box with extra seal and a lid, a 3D printed funnel for liquid injection, a fixed amount of volume of solution, and a colorimetric chart, as well as a user manual with clear instructions. And you might wonder what the McConkey powder is used for. Well, the McConkey powder contains an indicator that alters the color based on the change in pH. And to set up the product, the user will first inject the solution, provided solution into the box, and they'll shake gently the box to allow the powder and the solution to mix evenly. They'll then just leave the box in the room and wait for the process to be undertaken. For the users to better observe color change, we purposely designed the whole box in black except for the bottom, which is transparent, allowing the users to observe color change clearly through the observing window. The initial color of the solution should be violet, but as our engineered E. coli cell grow, it produces lactic acid, which lowers the pH value of the solution and changing the color from violet to yellow. Ideally, the bacteria cells, when sensing a certain concentration of formaldehyde, will generate luciferase to report, which will illuminate the whole culture medium. And if there is no luminescence detected in the culture medium, then it means that the environment contains a safe level of formaldehyde content. So we've created, I just mentioned that we gave the users a colorimetric chart. So we wanted to find out the relationship between concentration of bacterial cell and pH value. So after gathering data on an online paper, and under the supervision of our modeling teachers, we tried different models in our language and eventually came up with the correct function, the best function, which is marked in red. And we found six reference colors of 6 different pH of McConkey online. And by using Python, we created a colorimetric chart that includes 500 colors based on the 6 original colors. And using the data we have on bacterial cell concentration, we were able to establish 3 checkpoints that indicate the statuses of our product. Green represents that the product has started working. Orange represents that it is recommended to replace the product, and red means you need to replace it now. Well, we understand that the checkpoints are quite hard to distinguish, so we are keep modifying our experiment conditions, perhaps lowering the pH to make the check marks more distinguishable. There are many features of the Formaldehunters. For instance, we really consider the safety implications of our product. The pores of the filter screen should be 0.2 micrometer in diameter, allowing molecules such as formaldehyde to enter, but prevents bigger bacteria, harmful bacteria from escaping out. The product also adopts a waterproof package that prevents leaking, and we encourage proper disposal by recycling the used products. Also, the users can do quality check on their own by looking at the colors. And if the colors doesn't go as planned, they can always return the product and we can replace them. Our product is also user-friendly because we give them a clear user manual with their instructions. And we understand that our product design is not the perfect one. And so we will also wait for more data updated on our experiment to modify both technology and product design. At the same time as we are doing the experiments and designing our product, we didn't forget to fully engage in understanding everything about formaldehyde. So we collaborated and contacted Daddy Labs and Home Test, two third-party organizations, and acquired first-hand data. Out of the 400,000 rooms detected, nearly 50% of them contains formaldehyde content over the standard levels. And there are 16% of child rooms, which is the room that all the parents are so concerned about, contains formaldehyde over the standard level. And to make things worse, 28% of these contaminated households doubles or even triples the standard level, which is a terrible data. So we really want to raise awareness and make people pay attention to the significance of this issue. We established the formaldehyde manual and disseminated the manual in both US and China, as well as doing a public lecture in a Chinese high school. And we really want to share our advice and help people to effectively and inexpensively remove formaldehyde. We really want more people to join us in speeding up the process of government's regulation on formaldehyde. And we also had fun throughout the project. For instance, we collaborated with TU Delft and establishing a partnership program and improving each other's projects by getting feedbacks. And most importantly, we held the first ever Euro-Asian meetup. The meetup is the first cross-continent meetup in the iGEM history, and more than 20 teams from as many as 6 countries and regions participated. The meetup features creative formats such as interactive sessions, and we share additional focus on bioethics and biosafety, establishing the final safety video together with TU Delft. We want to thank all those who have helped us through the project. We want to thank TU Delft for collaborating with us. We want to thank all the teams who have participated in the Euro-Asian meetup. We want to thank EIC Education for sponsoring us. And lastly, we want to thank BGI College for getting our back, as always. And I want to thank all my team members who have contributed to this project, and our advisors who have given us so much advice and guidance. And lastly, thank you for your attention, and thank you for listening to our presentation. Thank you.
Very nice. Well done.